Hello children, how are you all? Hope so you are doing good. Yes, in the today's session we are going to solve the trigonometric identities from the latest version of Selina textbook class 10 ICSE. Keep in mind children, it's a one short session where we are going to cover all varieties of questions from trigonometric identities. So don't miss to watch the video till the end. So before we actually begin with the concept, let me remind you guys to subscribe my channel, that is Ignite Math ARP, if you have not yet subscribed. Let's not delay. Let us start with the problems on trigonometric identities. So now, first of all, children, you must know what are the trigonometric identities. We have some of the basic trigonometric identities. Let me write down the basic trigonometric identities. Okay. So other than these identities, there are many derived identities. Keep in mind, children. Okay. So the basic ones are sine square theta plus of cos square theta is equal to 1, which can be written in many forms in fact. Then the second one is secant square theta minus of tan square theta is equal to 1. This can also be written in many forms, children. And the third one is cosecant square theta minus of cot square theta is equal to 1. This also can be written in the many form. The whole chapter is completely based upon these three identities. But keep in mind, if you know only these identities, it is not sufficient. You are required to remember some of the algebraic identities also, like a plus b the whole square, a minus b the whole square, a plus b the whole cube, a cube plus b cube. All these identities are the trigonometric, algebraic identities, and these are the trigonometric identities what you need to remember to tackle the problems from the exercise. Now let's not delay, let's start with the exercise 21a. Here we have some of the multiple choice questions as well. Now choose the correct answer from the options given below. The question says sine to the power of 4 theta minus cos to the power of 4 theta is equal to. So what I write is sine to the power of 4 theta can be written as sine square theta the whole square minus of cos square theta the whole square. Now it looks like the identity a square minus b square. See, this is the algebraic identity. A square minus b square is a plus b, a minus b. Correct, children? So here I can write this one as a sine square theta minus of cos square theta, then sine square theta plus of cos square theta. So sine square theta plus cos square theta is 1. This will give you 1. So I'll keep this sine square theta minus of cos square theta as it is, and this can be written as 1 because the identity sine square theta plus cos square theta is equal to 1. If you see the options there is no such options. We have something in terms of sine over here and cos here, right? So what I do, I'll keep this sine square theta as it is minus of this cos square theta can be written as 1 minus sine square theta. Why? Because you must know, children, sine square theta plus of cos square theta is equal to 1. So if I want to make a cos square as a subject of formula, I will bring this sine square to the other side. That time cos square theta is equal to 1 minus sine square theta can be written. So now when I remove the bracket, it is going to be sine square theta minus 1 plus of sine square theta again, because minus into minus is plus. So sine square theta plus sine square theta, I'll be getting it as 2 sine square theta minus 1. So that option is there, 2 sine square theta minus 1. So option number 3 is the right answer. Clear, children? Now let me take the next one. 1 by sine A, 1 by 1 minus sine A is equal to. So what I do here, look at this, 1 by 1 minus sine A is there. I'll multiply this with 1 plus sine A by 1 plus sine A. So I can write this one as 1 into 1 plus sine A is 1 plus sine A itself. Then this can be, look at this, 1 minus sine A into 1 plus sine A it is, okay, which looks like the identity A minus B, A plus B, that is equal to A square minus B square. So this can be written as 1 plus sine A by, so 1 minus sine square A, 1 square minus sine square A. In fact, 1 square is 1 itself. Clear, children? So now I can write this one as 1 plus sine A divided by 1 minus sine square A is nothing but cos square A. Clear, children? The same logic is applied over here. So now what can I write this one? I can write this one as 1 by cos square A into 1 plus sine A. So 1 by cos square A is nothing but secant square A 1 plus sine A. So secant square A into 1 plus sine A, that is option number 2 is the right answer. See, children, trigonometric identity is the concept where you keep on doing, but you never arrive at the answer, but your solution is also not wrong. So you have to have a eye on what is RHS, what to be obtained. According to that, you have to simplify. Clear, children? So now let us proceed with the next type of questions over here. Prove the following identities. So whenever you are going to prove the given trigonometric identities, either you can take the LHS to prove it is equal to RHS, or you take RHS, prove it is equal to LHS, or simplify LHS to get one expression and simplify RHS to get the same expression. Then also you can say LHS is equal to RHS. So now what I do over here, children, I'll just consider the LHS. Look at this very carefully. LHS is what? Secant A minus 1 divided by secant A plus 1. So what I do, secant A minus 1, I can write this one as a secant A minus 1 divided by secant A plus 1. I'll just separate them with a division sign. Sec and cos are reciprocals of each other. Sec can be written as 1 by cos A minus 1. Then divided by this sec A, again I can write this one as 1 by cos A plus 1. So here if I take LCM, LCM is going to be cos A, then 1 minus cos A divided by 1 plus cos A by cos A I get. Clear, children? So what I'm going to write here, 1 minus cos A, I'm going to keep as it is, by cos A. Since it is division, I need to take the reciprocal over here, cos A by 1 plus cos A. So now cos A will be get cancelled, right? So now what I'm left with is 1 minus cos A by 1 plus cos A. If you look at the RHS, that is our RHS. Clear, children? I hope so this is clear. So now let's move to the next one. See, the question says that the fourth question, tan A minus cot A is equal to 1 minus cos square A you are supposed to prove, divided by sin A into cos A. So I will take the LHS here. It is not necessary that always you need to take LHS and prove it is equal to RHS. Sometimes you may require to take RHS, prove it is equal to LHS also. Clear, children? So now what I do here is I will take LHS. LHS is tan A minus of cot A divided by 1. Okay, need not be written. Okay, I'll not write divided by 1. Okay, better let's not get confused with that. I will not write any denominator because no denominator is given over here. So now what I do here is a tan A can be written as a sin A by cos A minus cot A can be written as a cos A by sin A. I hope so this is clear enough. So now if I take LCM, LCM is going to be sin A into cos A. So here cos A is there, so sin A is not there, so I need to multiply both the numerator and denominator with sin A. When you multiply the numerator with sin A, this becomes a sin square A. Clear? So similarly over here, this becomes a cos square A. Clear, children? So now if you observe the numerator of the RHS, there is no sin square, so I have to have only cos square. So what I do here is, this sin square can be written as 1 minus cos square A minus cos square A divided by sin A into cos A. Why? The reason to be written, children. So sin square theta plus of cos square theta is equal to 1. So sin square theta, I want to express it as cos square theta. This cos square is taken to the other side, so I can write this one as sin square theta is equal to 1 minus cos square theta. That is how I have expressed sin square in terms of cos square. So now I will keep this one as it is, minus cos square minus 2 cos square theta divided by sin A into cos A. If you look at the RHS, this itself is your RHS. So now I have obtained the RHS. This is clear, children. Let's move to the next one now. See, the question 8 says that 1 plus tan square A into cot A by cosecant square A is equal to tan A. I am supposed to prove. Clear, children? So now what I do, again I will take the LHS, that is 1 plus of tan square A into cot A divided by cosecant square A. Clear? So now what I do here is 1 plus tan square, children. You need to understand here, secant square theta minus of tan square theta is equal to 1. If I take this tan square to the other side, it becomes 1 plus of tan square theta is equal to secant square theta. Clear? So here I have 1 plus tan square theta, which can be written as secant square theta. So similarly here I have 1 plus tan square theta, which can be written as secant square A into cot A divided by cosecant square A. Clear, children? So now what I write over here, we need to understand very carefully, children. So secant square A. So now what I do here is, I will write them separately so that you understand it in a better way. Secant square A into cot A, it is, then into 1 by cosecant square A, it is. Correct, children? So secant square A can be written as 1 by cos square A into this tan cot A can be written as 1 by tan A into 1 by cosecant square A can be written as sin square A. So now this 1 by cos square into sin square will give you sin square A by cos square A into 1 by tan A. So now what happens, children? Sin square A by cos square A is tan square A. Tan square A into 1 by tan A. So 1 tan A will get cancelled. So I will be left with what, children? Tan A. So that is equal to your RHS. Is that clear to you? Right. So now let's proceed with the next question. See, cosec A plus sin A, cosec A minus sin A, it is equal to cot square A plus cos square A, you are supposed to prove. Clear, children? So now what I do over here is, see, again I will take the LHS. What is LHS? LHS is cosec A plus of sin A, then cosec A minus of sin A. So cosec A plus sin A, cosec A minus sin A, which looks like the identity A plus B, A minus B is equal to A square minus B square. This is the identity. So here I can write this one as a cosecant square A minus of sin square A. Correct, children? So now what can I write? So look at this. I want a cot square and a cos square. So cosecant square can be written as a 1 plus of cot square A. Right. This I have written in place of cosecant square A. minus I'll keep as it is. Sin square A can be written as 1 minus of cos square A. So when I remove the bracket, 1 plus of cot square A minus 1 minus into minus is plus cos square A. So plus 1 minus 1 will get cancelled. So I can write this one as a cot square A plus of cos square A. So that is equal to RHS. This question seems to be very simple, children, when you see the solution, but when you are trying on your own, you get stuck. You need to have an eye on the RHS and simplify the LHS according to what is required in the RHS. So now let us proceed with the next question, that is question number 13. So here again I will take the left hand side, that is 1 by sec A plus of tan A. Clear, children? So what I do here, I will multiply this one with sec A minus tan A, because I need sec A minus tan A in the RHS. So divided by, if I am multiplying the numerator with sec A minus tan A, denominator should also be multiplied with sec A minus tan A. So 1 into sec A minus tan A is sec A minus tan A itself, divided by, again it looks like the identity, A minus B, A plus B, which is equal to A square minus B square. So I can write this one as secant square A minus of tan square A. So numerator secant A minus of tan A, I'm going to keep as it is. So secant square A minus tan square A is 1. Why? The reason should be given. Secant square theta minus of tan square theta is equal to 1. So I'll be left with secant A minus of tan A, that is equal to RHS. Clear, children? Right? So let us move with the next question, that is question number 15. So here again I will take the LHS. Now let us see what happens if I take the LHS. LHS is secant square A into cosecant square A. So secant square A, see here I have only tan and cot. Secant square A can be expressed as 1 plus tan square A into cosecant square A can be expressed as 1 plus of cot square A. Here, children, you can write the identity. Why? Because secant square theta minus of tan square theta is equal to 1, or cosecant square theta minus of cot square theta is equal to 1. These are the reason for your step. Now I'll apply the distributive property and multiply them. 1 into 1 is 1, plus of 1 into cot square theta is cot square A itself, then tan square A into 1, that is tan square A, plus of tan square A into cot square A. So tan square A into cot square A. So here what I write, I'll write 1 plus of cot square A plus of tan square A plus of tan square A into, you know that cot and tan are reciprocals of each other. So cot square A can be written as a tan square A. So this tan square will get cancelled. 1 plus cot square A plus of tan square A plus of 1 will remain over here. So I'll be left with what, children? I'll be left with tan square A plus of cot square A plus 2, that is equal to RHS. I hope so it is clear enough. So now let us move to the next question, that is question number 17. Okay, so in the question number 17, again I'm going to take the LHS. Look at this very carefully, that is cosec A by cosec A minus 1 plus of cosec A by cosec A plus 1. I'm supposed to prove it is equal to 2 secant square A. So now I will take the LCM. if I take the LCM, please observe it very carefully. So it is going to be like cosec A minus 1, then cosec A plus 1. Here this is going to be cosec A, cosec A plus 1, then plus of cosec A, then cosec A minus 1, because this numerator to be multiplied with the other denominator, this numerator to be multiplied with the other denominator. So now when I multiply this cosec A into cosec A, I'll get it as cosecant square A plus of cosecant A plus of again cosecant square A minus of cosecant A divided by, so the denominator looks like a plus b, a minus b, which is equal to a square minus b square. So I can write the denominator as cosecant square a minus 1. So here minus cosec a plus cosec a will get cancelled. I'll be left with 2 cosecant square a divided by, if you observe carefully, cosecant square a minus 1 is there. Okay, so that is nothing but a cot square a. So why it is so, you must know that cosecant square theta minus of cot square theta is equal to 1. So if I bring this 1 from the right hand side to left hand side, and if I take this cot from the left hand side to right hand side, it becomes cosecant square theta minus 1 is equal to cot square theta. So that's why I have replaced cosecant square a minus 1 by cot square a. Clear, children? So now what can I write over here is 2 into cosecant square a into 1 by cot square a. So this in fact can be written as 2 into, you know that cosec and sine are reciprocal. So 1 by sine square a into, again here I can write cot square as tan square a. So that is equal to 2 into 1 by sine square a into, this can be written as sine square a by cos square a. So sine square will be get cancelled. So I'll be left with what? 2 by cos square a. So that is nothing but 2 into 1 by cos square is nothing but secant square a. So that is equal to RHS. Clear, children? I hope so. This is clear enough. So now let me take the next question, that is question number 20. Okay, so in the question number 20, so again I'm going to take the, let us take this for a change, I will take the RHS. All right, LHS also you can take it, children, no issues. You can take RHS as well. Right, so now what I do, RHS is secant a minus of secant a minus tan a the whole square. So now which looks like the identity a minus b the whole square. A minus b the whole square is a square plus of b square minus 2ab. So I can simplify this one using that identity, secant square a plus of tan square a minus of 2 secant a into tan a. Clear, children? So secant a can be written as 1 by cos square a, and tan square a can be written as sin square a by cos square a minus of 2 into sec a is 1 by cos a into sin a by cos a. So if I take the LCM, everywhere it cos square is there, so I can take cos square a as the LCM. So this becomes 1 plus of sin square a minus of 2 sin a. Okay, so now this looks like, see here, it looks like a square plus b square minus 2ab, which is equal to a plus b the whole square. Clear? So I can write this one as 1 minus sin a the whole square divided by cos square a. I hope so. This is clear, children. So next what I do here, I can write this one as 1 minus sine A into 1 minus sine A, because whole to the power of 2 is there, divided by 1 minus sine square A. Why it is so? Because sine square theta plus of cos square theta is equal to 1. So cos square theta is equal to 1 minus sine square theta. So now I can write this one as 1 minus sine A into 1 minus sine A divided by, here again it looks like a square minus b square, which is a plus b, a minus b. So 1 plus sine A, 1 minus sine A. So 1 minus sine A, 1 minus sine A will get cancelled. So I'll be left with 1 minus sine A, 1 minus sine A divided by 1 plus sine A, that is equal to RHS. Clear, children? Okay, see, I have to have an I over there, okay, in the LHS or RHS. See, I have taken RHS, so this is going to be LHS because I have taken RHS and simplified to get the LHS. Okay, children? Yes, children. Now let us see the next question. Next question says that tan square A minus tan square B is equal to sin square A minus sin square B by cos square A into cos square B. I'm supposed to prove it. Okay, so now here I will just consider the LHS again. So LHS is tan square A minus of tan square B. So now what I write tan square A as? I can write tan square A as sin square A by cos square A minus of sin square B by cos square B. Now if I take the LCM is going to be cos square A into cos square B. Then this becomes sin square A into cos square B minus of sin square B into cos square A. If you observe the numerator of the RHS, only sin square is there, no cos square. So what I do here is I'll keep the sin square A as it is and express cos square in terms of sin square. So I can write this cos square B as 1 minus sin square B minus of sin square B as it is. Again express this cos square A as 1 minus sin square A. So divided by the denominator, I am going to write as it is cos square A into cos square B. Now when I multiply this, I'll get it as sin square A into, minus sin square A into sin square B, because once with this and once with this I need to multiply, minus of sin square B, minus into minus is plus of sin square B into sin square A. So I'm going to retain the denominator as it is, that is cos square A into cos square B. So sin square A into sin square B, sin square A into sin square B, both of them are having opposite sign, they get cancelled. So I'll be left with what, children? So I'll be left with sin square A minus of sin square B. See here, sin square A is here, sin square B is over here, divided by cos square A into cos square B, that is nothing but the RHS what we require. Clear, children? So let's move to the next question, that is question number 27. Now again I will take LHS. LHS is square root of 1 plus sin A by 1 minus sin A. Now what I do here is I will multiply both the numerator and the denominator, which is inside the square root sign, that is 1 plus sin A, 1 minus sin A, with 1 plus sin A by 1 plus sin A. So it won't make any difference to the given expression. So numerator becomes here sin A, 1 plus sin A into 1 plus sin A, 1 plus sine A the whole square by, if you observe the denominator, it looks like a plus b, a minus b, that is 1 minus sine square a. So now again I will write square root sine. So 1 plus sine a the whole square by this 1 minus sine square a can be written as cos square a. The reason is what? Sine square theta plus of cos square theta is equal to 1. So now both together can be written as 1 plus sine A by cos A the whole square, right? Square and square root will get cancelled. Later I'll be left with 1 plus sine A by cos A. So the cos A belongs to both the terms in the numerator. 1 by cos A plus of sin A by cos A. So 1 by cos A is sec A, then sin by cos is tan A. So that is equal to RHS what we require. Clear, children? So now let's move to the next one. Next question says that 1 by sin A plus cos A plus 1 by sin A minus cos A. I'm supposed to prove it is equal to 2 sin A by 1 minus 2 cos square A. So now I will take the LHS. Pay attention. So LHS is what? 1 by sin A plus cos A plus of 1 by sin A minus cos A. So if I take the LCM, LCM is going to be sin A plus cos A, then sin A minus cos A. So here it is going to be like sin A. This denominator need to be multiplied with this denominator. So numerator should also be multiplied with the sin A minus cos A. Sin A minus cos A plus of sin A plus cos A. So minus cos A plus cos A get cancelled. Sin A plus sin A, I'll get it as 2 sin A divided by A plus B, A minus B it looks like. So I can write this one as a sin square A minus of cos square A. So numerator I'm going to retain as it is 2 sin A divided by, see RHS is having only cos. So I will express this sin square in terms of cos. So 1 minus cos square A minus of cos square A. So that is equal to 2 sin A as it is by 1 minus cos square A minus of cos square A. So that is equal to 2 sin A as it is. Then I can write this one as 1 minus 2 cos square A. So that is equal to the right hand side what is required. Clear, children? So now let us move to the next one, that is cos theta into cot theta by 1 plus sin theta is equal to cosec theta minus 1. Clear, children? So now what I do here is I will just consider the LHS over here. So LHS is what? It is cos theta into cot theta divided by 1 plus sin theta. Clear? So now what I write over here, children, cos theta into cot theta is there in the numerator. So what I can write this one as cos theta into cot theta can be written as cos theta by sin theta. Clear, children? So this divided by, here I have 1 plus sin theta, I will write in this way. So now when I multiply cos theta into cos theta, I'll get it as a cos square theta divided by sin theta as it is into 1 by 1 plus sin theta. Now observe carefully, children. So cos square theta here I can express it as 1 minus sin square theta divided by sin theta into 1 plus sin theta. So next step, what can I write? Here is, it looks like a square minus b square, which is a plus b, a minus b. 1 plus sin theta, 1 minus sin theta divided by So sin theta 1 plus sin theta denominator as it is. Now I can cancel 1 plus sin theta, 1 plus sin theta. So I'm left with what, children? 1 minus sin theta divided by sin theta. So here again I will separate the denominator, 1 by sin theta minus of sin theta by sin theta. 1 by sin theta is cosec theta minus 1, because sin theta will get cancelled. So that is equal to RHS, what I am supposed to get. Clear, children? So now let's take the exercise 21B. Right. So in the 21B, again we have multiple choice questions in the beginning. Right. So now let us see what actually the multiple choice question says and how to write the correct answer. So what is the expression given over here? 1 plus cot square A, then plus of 1 plus tan square A is equal to. Children, multiple choice question doesn't mean that you can just pick the answer from the options. No, you need to work it out. There are also 3 or 4 mark questions in fact. Okay. So now what can I write over here is, look at this very carefully, children. I will write, I'll just multiply this better, 1 into 1. So first I'll multiply this, 1 into 1 is 1, then 1 plus tan square A plus of, again with cot square I'll multiply, cot square A plus of tan square A into cot square A. Clear, children? So now if you observe this, 1 plus tan square A can be written as secant square A plus of here cot square A is there, cot square A is there, cot square A I will take out common, then I'll be left with 1 plus tan square A. Clear? So now secant square A I'll keep as it is, again cot square A into 1 plus tan square is, again I can write this one as secant square A. Again I'll have secant square A common over here, so I'll take out secant square A common, I'll be left with 1 plus cot square A. So now I can write this one as secant square A, so into 1 plus cot square A is nothing but cosecant square A. So what is the right answer? Secant square A into cosecant square A. That is a fourth answer. Fourth option is the right answer. Now let us move to the next question, that is again a multiple choice question. Right. So now it is given to you that cot A minus of cot B the whole square plus of 1 plus cot A cot B the whole square. So now I'll expand this one using A minus B the whole square formula. So I'll get this one as cot square A plus of cot square B minus of 2 cot A into cot B plus, again I'll expand this one using A plus B the whole square formula, that is 1 square is 1 itself, plus of cot square A into cot square B plus of 2 into 1 into cot A cot B. So 2 cot A cot B and 2 cot A cot B will get cancelled because they are having opposite sign. So I'll be left with what, children? Cot square A plus of cot square B plus 1 plus of cot square A into cot square B. Clear? So now what I do is cot square A plus 1. This one I'll bring it over here, plus of cot square B plus cot square A into cot square B I will write. Clear? So here you know that 1 plus cot square A is a cosecant square A plus of, here I will take out cot square B common, 1 plus cot square A will remain inside. So here cosec square A plus of cot square B. So here I can write this one as 1 plus cot square A is nothing but again cosecant square A. So again I can take out cosecant square A common. So cosecant square A is taken common. So inside the bracket 1 plus cot square b is left. So I can write this one as cosecant square a into 1 plus cot square b is what, children? Cosecant square b. So I'll get the answer as cosecant square a into cosecant square b. That is fourth option is the right answer. Clear, children? So now let's move to the next question, that is secant a minus secant minus tan a the whole square into 1 plus tan a is equal to 1 minus sin a you are supposed to prove. So now I will consider the left hand side, that is secant a minus of tan a the whole square 1 plus sin a I will take it as. So now here secant a is nothing but 1 by cos a minus of sin a by cos a whole square 1 plus sin a I'm keeping as it is. So inside the bracket, when I take the LCM and simplify, LCM is going to be cos a. So 1 minus sin a the whole square. So 1 plus sin a as it is. So now I can separate this square. I can write this one as 1 minus sin a the whole square divided by cos square a into 1 plus sin a. Clear, children? So here I know that it is twice written. So what I do here, 1 minus sin a into 1 minus sin a divided by, so what I do here, cos square a can be written as 1 minus sin square a into 1 plus sin a, which is outside the bracket. So now the numerator to be kept as it is, that is 1 minus sin a into 1 minus sin a. Denominator looks like a square minus b square, which can be written as 1 plus sin a into 1 minus sin a. Again this 1 plus sin a I'm going to keep it as it is, 1 plus sin a. So 1 plus sin a, 1 plus sin a, 1 minus sin a, 1 minus sin a will get cancelled. So I'll be left with 1 minus sin a, that is nothing but the RHS, right hand side. I hope so you are following whatever we are doing. So the next question is, look at this question very carefully. So I will take the LHS. So LHS is what, children? So tan a plus of 1 by cos a the whole square plus tan a minus of 1 by cos a the whole square. So here 1 by cos a is there, either directly you can write it as secant, right, or if you want you can convert them as sin and cos, that can also be written. So what I do here is sin a by cos a plus of 1 by cos a the whole square plus here again sin a by cos a minus 1 by cos a the whole square. If I simplify within the bracket, I would get this one as cos a, then sin a plus 1 the whole square over here and whole square over here, that is plus, then again sin a minus 1 the whole square divided by cos a the whole square. I hope so you are following it, children. So later cos a the whole square, cos a the whole square, I can take the LCM as cos square a, and the numerator is sin a plus 1 the whole square plus of sin a minus 1 the whole square. So sin a plus 1 the whole square. So sin square a plus 1 plus 2 sin a. Okay. Then plus sin square a plus 1 minus 2 sin a. So divided by. So I'm going to keep this cos square as 1 minus sin square a. You can write the reason here. Sin square theta plus cos square theta is equal to 1. So now 2 sin a plus and minus will get cancelled. I'll be left with what, children? 2 of sine square a plus 1 divided by 1 minus sine square a. Clear, children? So this is what is required. See, sine square a plus 1 is same as 1 plus sine square a. So I can rewrite this one as 1 plus sine square a divided by 1 minus sine square a. Since commutative property holds good in addition, you can keep it in this way also. Doesn't matter. Clear, children? So now let us move to the next one. If you permit me, I'll just drink a sip of water. Yes, now let us see the next question, that is question number 5. Okay, that is what the question is. 2 sine square a plus cos to the power of 4a is equal to 1 plus sine to the power of 4a you are supposed to prove. So I will just take the LHS. LHS is what, children? 2 sine square a plus of cos to the power of 4a. So what can I write over here? 2 sine square a, I am keeping as it is. Cos square a can be written as cos to the power of 4a can be written as cos square a the whole square. Right. So now I can write this one as 2 sine square a plus of this cos square a is 1 minus sine square a the whole square. So 2 sine square a plus 1 plus sine to the power of 4a minus 2 sine square a, because a minus b the whole square is equal to a square plus b square minus 2ab. Right. So 2 sine square a with plus sign and minus sign will get cancelled. So I'll be left with 1 plus sine to the power of 4a, that is equal to RHS. Clear, children? So now let us move to the next question, that is the 9th question. Here again I will take the LHS. So look at this very carefully. So LHS is 1 divided by cos a plus sin a minus 1 plus of 1 divided by cos a plus sin a plus 1. So what I do, I'll group this as one term, right? See, both of them are cos a plus sin a, cos a plus sin a. This looks like minus 1 plus 1, so which looks like a minus b, a plus b. So again I need to multiply this numerator with this denominator, so I'll be getting this one as cos a plus sin a plus 1 plus of cos a plus sin a minus 1 divided by a plus b, a minus b is a square minus b square. So cos a plus sin a the whole square minus of 1 square, that is equal to 1 itself. So now I'll be having 1 plus and 1 minus, so they get cancelled. So now I can write directly that 2 cos a's are there, so I can write 2 sin a plus cos a. Clear, children? So and expand the denominator using a plus b the whole square formula. So I get this one as cos square a plus of sin square a plus of 2 sin a cos a minus 1. So numerator I'm going to keep as it is, 2 sin a plus cos a, and divided by, see, this cos a plus cos square a plus sin square a can be written as 1 plus of 2 sin a cos a minus 1. This plus 1 minus 1 will get cancelled. So I'll be left with what, children? 2 into sin a plus cos a divided by 2 sin a cos a. So this 2 will also get cancelled. Now denominator belongs to both the numerators. So I can write this one as sin a by sin a cos a plus of cos a by sin a cos a. So here sin a will get cancelled, 1 by cos, that is sec a. Here cos A will get cancelled, 1 by sine, that is nothing but cosec A. So sec A plus cosec A, that is equal to RHS I am getting. Clear children? That is about the question number 9. Now let us see the next question. So if m is equal to a sec a plus b tan a and n is equal to a tan a plus b sec a, then prove that m square minus n square is equal to a square minus b square. So again I will take the left hand side, that is m square minus n square. So what is m? M is this whole term. So I'll replace this m by a sec a plus b tan a the whole square minus of, then n is a tan a plus b sec a the whole square. So now a plus b the whole square formula. So a square secant square a plus b square tan square a plus of 2ab secant a tan a minus of, directly I will write, I'll just remove the bracket directly. So I'll get it as a square tan square a minus b square secant square a minus of 2ab tan a sec a. So one with plus sign and one with the minus sign will get cancelled. So now I'll bring all the term which has a square. Alright, so I can write this one as a square secant square a minus of a square tan square a plus of b square tan square a, then here it is, right? So minus of b square secant square a. So now I can take out a square common, then I'll be left with secant square a minus of tan square a plus b square is taken common, then I'll be left with tan square a minus of secant square a. So you know the identity, secant square theta minus tan square theta is 1 plus of b square into, this is tan square theta minus secant square theta, which is nothing but minus 1. So I'll be writing this one as a square minus b square, that is equal to RHS. I hope so this is clear with everybody. So now let us go to the next exercise, that is test yourself. Okay, there is an exercise called as test yourself. Actually you are supposed to test yourself, but let me test yourself. Okay, so now here you're asked to prove the following. So again I will take the LSS, since it is a revision exercise children, I'll be taking only few examples from this exercise. So LHS I'll be taking 1 by cos A plus sin A plus of 1 by cos A minus sin A. Clear children? So I will take the LCM. LCM is going to be cos A plus sin A, then cos A minus sin A, by here this numerator to be multiplied with this. So cos A minus sin A plus of cos A plus sin A. So here sin A will get cancelled. I'll be left with 2 cos A divided by, denominator looks like a plus b, a minus b. So I can write this one as cos square A minus sin square A. Clear? So I need to have everything in terms of cos in the denominator. So what I do over here, 2 cos A, already I have got the numerator what I'm supposed to get. So here I want only cos, so I'll just remove this sin square. So cos square A minus of 1 minus cos square A I can write. So that is equal to 2 cos A divided by cos square A minus 1 plus of cos square A. So that is equal to 2 cos A divided by 2 cos square A minus 1. So that is equal to RHS. Children, you are supposed to give the reason wherever, whichever identity you are using, you need to mention the reason. If you don't mention the reason, you are going to lose the marks, keep in mind. So I have also used the identity sin square theta plus cos square theta is equal to 1. Clear, children? So now let us move to the next question, that is the sixth one. So here in this question, observe the question carefully over here. So question says that 1 plus secant a minus tan a the whole square. So again I will take the LHS. LHS is 1 plus sec a minus tan a the whole square divided by cosec a, then sec a minus tan a. This is the LCM. So what I will write over here, children. So now I'll just keep this one as it is. Then here I'll expand this one using a minus b the whole square formula. So secant square a plus of tan square a minus 2 sec a tan a divided by, so denominator I'm going to retain as it is, cosec a into sec a minus tan a, right? So now here if you observe carefully, 1 plus tan square can be written as a secant square a plus this secant square a I'm going to keep as it is minus of 2 sec a and tan a. So denominator I'm going to retain as it is cosec a, then sec a minus of tan a. So here secant square a I'm going to get it as 2 secant square a minus 2 sec a tan a divided by cosec a, then sec a minus of tan a. Clear, children? So in the next step, 2 secant a I will take out common. So I'll factorize this. 2 secant a I have taken common. Then I'll be left with sec a minus of tan a divided by cosec a, then sec a minus of tan a. So sec a minus tan a, sec a minus tan a will get cancelled. So I can write this one as 2 sec a into 1 by cosec a. So 2 sec a, 2 into 1 by cos a, right? 1 by cosec a can be written as sin a. So 2 into, I'll get this one as sin a by cos a, that is equal to 2 into tan a. So that is nothing but right hand side. Clear, children? So now let us move to the next question. See here, square root of secant square a plus cosecant square a is equal to tan a plus cot a you are supposed to prove. So again I will take up the LHS over here. So square root of secant square a plus of cosecant square a. So square root of secant square a can be written as 1 plus tan square a plus of cosecant square a can be written as 1 plus cot square a. You must know the identity, that is secant square theta minus of tan square theta is equal to 1. Cosecant square theta minus of cot square theta is equal to 1. So now I can write this one as, look at this carefully. So tan square theta, okay. So here tan square a plus of cot square a plus 2, correct? So 1 plus 1 is 2. So now I can write this one as tan square a plus of cot square a plus 2. Here I can write this one as tan a into cot a. Why I have written tan a into cot a? You must know that tan a into cot a is equal to tan a into 1 by tan a it is going to be. So they both get cancelled. It is same as 1. So this whole term is same as 1. So it is only 2 over here. So instead of 2 I have written as 2 tan a cot a. Why I have written like that, because I want it to be looking like a square plus b square plus 2ab. So where I can write this one as tan a plus of cot a the whole square. So the square and square root get cancelled. So I'll be left with what, children? Tan a plus cot a. So that is equal to RHS. Clear, children? Right. Now let us see the next question. Right, so the next question, most probably this is going to be the last question of the session. Right, so now look at the question carefully. I need to prove this equal to this as well and this equal to this as well. Right, so now I'll consider the LHS for the first part. So what is the LHS, children? That is cot square A minus of cot square B. Cot square A can be written as cos square A by sin square A minus of cos square B by sin square B. So when I take the LCM is going to be sin square A sin square b, then cos square a into sin square b minus of cos square b into sin square a. Clear, children? So if you observe carefully, everything is in terms of cos square. So I will express each and every term of sin square as cos square in the numerator. So cos square a 1 minus of cos square b minus of cos square b 1 minus of cos square a. So divided by sin square a into sin square b. So now when I remove the bracket, it is going to be cos square a minus of cos square a into cos square b minus cos square b plus of cos square a into cos square b. So denominator I am going to retain as it is, that is sin square a into sin square b. If you observe carefully, cos square a cos square b plus and minus sign will get cancelled. So what I am left with, children? I am left with cos square a minus of cos square b divided by sin square a into sin square b. So I have got this one. So next I'm going to prove the second part. Again I will consider this, that is LHS. Look at this very carefully. Cot square a minus of cot square b is there. So what cot square a can be written as a cosecant square a minus 1, right, children, minus of c, children. This is cot square b is there. Again I can write this one as a cosecant square b minus 1. So when I remove the bracket, this is going to be cosecant square a minus 1 minus of cosecant square b plus 1. So minus 1 plus 1 will get cancelled. So I'll be left with cosecant square a minus of cosecant square b. Okay, so that is what you are supposed to get. So I can write hence proved. So what can I say, children? In all this kind of identity, you need to have a look at the RHS and simplify the LHS accordingly using the algebraic identities or the trigonometric identities. So thank you so much. Don't forget to subscribe the channel, like the channel, and share the video with your friends. See, that is nothing but the motivation for me, children, which motivate me to do more videos of this kind which you can use and score good in the exam. So take care, keep working, bye bye.